Hi, this is Alex from devstories.eu. Kubernetes and Helm Fundamentals, Episode 2 of 10. You have dozens of servers running hundreds of containers. When a machine suddenly fails, something has to decide where those orphaned workloads go next. An orchestra without a conductor is just noise, and a fleet of containers without a centralized brain is unmanageable chaos. That centralized brain, along with the machines doing the actual work, form the Kubernetes cluster architecture. A Kubernetes cluster is split into two distinct halves. You have the control plane, which acts as the brain, and you have the worker nodes, which act as the brawn. The control plane makes all the global decisions, like scheduling workloads, and it detects and responds to cluster events. The worker nodes host your applications and execute the instructions sent by the control plane. Every cluster must have at least one worker node to run applications. Look at the control plane first. Its primary component is the Kube API server. Listeners sometimes hear API server and picture a standard web server handling HTTP requests for an application. That is not what this is. The Kube API server is the central nervous system of the entire cluster. It is the front end of the control plane. Every single communication, whether it comes from a human operator, a worker node, or an internal component, routes through this API server. Because the API server is completely stateless, the cluster needs a memory. That is etcd. This is a consistent, highly available key-value store containing all cluster data. Whenever a configuration is created or a system state changes, the true record of that change lives in etcd. Next is the Kube scheduler. When you ask the cluster to run a new container workload, that workload initially has no assigned machine. The scheduler spots this unassigned workload. It evaluates resource requirements, hardware constraints, and policy rules, and then assigns the workload to the most appropriate worker node. Finally, you have the Kube controller manager. This component runs continuous background loops called controllers. These controllers constantly watch the current state of the cluster through the API server and actively work to push that current state toward your desired state. If a worker node crashes, the controller manager notices the missing machine and triggers the response to replace the lost workloads. That covers the brain. Now look at the worker nodes executing the tasks. Node components run on every single worker machine to maintain the runtime environment. The most critical component here is the kubelet. This is an agent running on every node that communicates directly with the control plane. The kubelet takes instructions from the API server and ensures that the required containers are actually running and healthy on its specific machine. The kubelet does not start the containers itself. It delegates that task to the container runtime. The runtime is the actual software, like Containerd, responsible for pulling container images from a registry and starting the processes on the operating system. Lastly, there is the Kube proxy. This is a network proxy running on each node that maintains the local network rules that allow network communication to reach your containers from inside or outside the cluster. Here is the key insight. The control plane dictates what should happen, but it never executes the application code. The worker nodes run the application code, but they rely entirely on the control plane to tell them what to run. This strict separation of decision-making from execution is what allows Kubernetes to scale horizontally and recover from hardware failures automatically. That's all for this one. Thanks for listening, and keep building.